Okay, let's look at number 3. Is it consider the function hx equals a times by negative 2x plus 1 to the 5th power minus b, where a is not equal to 0 and b is not equal to 0 are constants. A, b are constants, okay? So first thing first, they would like to ask you to find out the h derivative. So when you do h derivative, you simply do what? Do the power rule, right? So when we do, let's put the a here, okay? H derivative. That's the time. First, we use the power rule. The 5 here, put in front. A is the constant, just leave it there. So you have 5a times by negative 2x plus 1 to the 4th power, right? And the derivative of the negative b is a constant, so that's 0, so no more. So we find the first derivative now. And then we go to, okay, so we did the derivative of h function, right? And then we can do the second derivative. So when you find the second derivative of x, oh, wait a minute. So this one is not finished yet. The first derivative equals to 5a times by negative x plus 1, right? The 5th power change to the 4th power. And then you gotta do what? The chain rule part, right? Chain rule do this part. You will have what? Negative 2 there. Because this one, negative 2x plus 1 derivative is just negative 2. So now you can get what? Continue with the first derivative, okay? Simplify. So when you do the simplify, negative 2 times 5, you have negative 10. A negative 2x plus 1 to the 4th power. And then we go to the b, the second derivative now, okay? When you do the second derivative, so you need to do is power rule again. So negative 10a is constant, leave it there. And then there's power of 4 put in front. So you're gonna have negative 40. Negative 40a and the negative 2x plus 1, reduce power by 1, you got 3, and then time by what? The chain rule part here. You go negative 2 there, right? So you will get what? Positive 80, negative 40, negative 2, positive 80a, and negative 2x plus 1, 3rd power. Okay? So this one you got a second derivative. We finish the b. I'll finish the a now. So generally, when you do the derivative, simply just what? Use the power rule and the chain rule to do the inside part. Don't forget that. Okay, and the constant derivative will be 0. Okay, now here they said show that h is monotonic. That means either always increasing, always decreasing, or constant. To show the function increasing or decreasing, basically we look at what? We look at the derivative. We look at the first derivative. So this is the first derivative here. See that, right? And this first derivative, you can see this part, no matter what the x is, this part will be positive. And then a is not equal to 0, but it's constant, and negative 10. So if a is negative, overall will be positive. If a is negative, if a is negative, the overall is positive. If a is positive, the overall is negative. So from here we can tell this h derivative of x either greater than 0 or less than 0, depends on the a, right? So That means what? If it's greater than 0, the hx function always increasing. And if this hx is less than 0, the hx always decreasing. So that's what they call the monotonic, right? So let's look at the third one now here. Show that x coordinates of the locations of critical points are independent from A to B. First thing first, we need to know what's the meaning about the critical point. The critical point here show the x coordinates of the critical points. For the critical points means only what? The edge derivative must be equal to 0, right? So we make edge derivative equal to 0 first. When you make this one equal to 0, you will have negative 10a, right? I copied here, okay? And then negative 2x plus 1 to the fourth power equals 0. And then from there, you can divide it by negative 10a divided by negative 10a to find what? Negative 2x plus 1 to the fourth power equals 0, right? You see, we're trying to find what's x coordinates right now. So critical point means either first derivative of the function not defined or equals 0. So here it's not defined, so it belongs to 0. So when you got this one now here, you have negative 2x plus 1 equals 0. And then you minus 1, you will get negative 2x equals negative 1, x equals what? Negative half. Easier? This is the x coordinate of the vertex, critical points. And this one not related to anything with A, because A is not appears here. Actually, A here is canceled already. So that's why you can see that derivative, the critical points, x coordinate of the critical points is independent from A. And also independent from B because the edge derivative never had anything with the B here, no B here. So that means whatever the value of the B, no problem with the x coordinate of the critical point. And of course, from here you can see that doesn't matter with A and B, right? So that's the way we do this kind of question. The basic thing we do this one here, we got to be careful that for this whole question, one thing is what here? Derivative greater than 0, function increasing. Derivative less than or equal to 0, function decreasing. The other one is what? When you do the derivative, don't forget to use the chain rule to do the part inside under the parentheses. And also definition for critical point is what? Edge derivative equals 0. This is definition for what? The critical point. Okay? So if you have any questions, please let me know. Thank you. Bye-bye.